Hello and welcome back to our introduction to OpenBIS. We now want to focus a bit on how do we store data in OpenBIS. So this goes to the second part of what OpenBIS is for. First of all, we discussed the electronic lab notebooks, but now we discuss a bit more on data management. In the electronic lab notebooks, we have seen how we can use OpenBIS to track our instruments, our samples, record the results of our experiments, and so on. But what happens if we have a little more data than just a single number that we want to store? For example, we can have tabular data or sloppy, and anything that fits into Excel. So these can be single values like the hardness or volume fraction, but also XY data like the strain data or any other plot, 2D plot that we can make. You can also have time series data if we make many measurements across time. Furthermore, we can also have unstructured data, i.e. images or text, like for example, TEM, SEM images, EBSD images, atom probe data, and so on, or any other specialized data type. So all of this needs to be maintained and tracked by our OpenBIS system as well. So there are a few ways how we can do this. In the default setting of OpenBIS and the way it's envisioned by the developers, that all data are managed by OpenBIS itself and can be retrieved to the local computer if necessary. So that means if you have a very large cluster setup on which OpenBIS is hosted, we can do all of this. Then we can upload the data, for example, with a web GUI, a Dropbox, or a custom import, and we'll discuss each of those in subsequent presentations. Here we want to start with the simplest one, the data upload via the web GUI. So here we go, for example, to our demo measurement that we've encountered previously, and we can click on the upload button. If we do this, a new field will open up where we create a data set. Here we first need to specify the data set type. That depends, of course, on what you've done, if you've done APT or SEM or TEM and so on. Then we can select the files to upload. As a simple example, we choose raw data. So this is really a placeholder for everything that is not treated by more specialized data types. We just use it here for illustration, but in your actual work you should choose the appropriate data type. Then you click Save, and you can see that now, indicated by the red arrows, the data are now attached to the measurement. Note that if you do this, you need to enter all the metadata for the file manually when uploading this way. So it's best for files that do not have a lot of metadata and are also quite small to upload this way. A better way for data that is already enriched with metadata is to use the Dropbox facility. So many of our data formats contain a lot of metadata, and these Dropboxes that have nothing to do with a commercial tool, these Dropboxes are special folders on the local computers and on the OpenBIS server. So they need to be established by the admins before you can use them. And they monitor the incoming data, extract the metadata automatically and open them to OpenBIS, and that then puts the data into the appropriate place in OpenBIS for like the experiment or the project and so on, and also adds own metadata automatically. So the following will need to be done by the admins or project 07 for you to be able to do this. This Dropbox needs to be configured, and it needs to be done per instrument. We also need to write the metadata extraction tool. Unfortunately, this is a sort of manual process because we need to reverse engineer the data format that is created by each individual instrument. So we need to do this each time for each instrument. Since all of these instruments are open source, we need to sort of read the data manually and see how we can reverse engineer this. And once we have done this, then we can install the Dropbox folders. So how do we do this? How do we use Dropboxes? First of all, we don't use the upload button, but we go to the More field, and then there is a dataset helper tool for the Dropboxes. This has the advantage that we can now trigger the scripts that read the metadata from the file. Probably we'll all be able to do this at IAM because of the network and security restrictions though. So if we use this dataset helper tool, it allows us to create a special folder name. First of all, we need to choose the correct dataset type, for example, SE image, and then we give it a suitable name. Once we have done this, the helper tool will auto-generate us a very long string. And this string encodes essentially all information that OpenBIS needs to identify the dataset type, but also the location where the new data should be linked to. And then we'll cover this in a more detail, how you can do this on a web interface. There's a thing called custom import that uses the same metadata extraction scripts. We said earlier that in the default setting, all data managed by OpenBIS can be retrieved to the local system, and it's all stored within the OpenBIS system. That assumes that OpenBIS runs on a sufficiently large and powerful system, but unfortunately, due to various constraints, this is not true for the CRC. So that means that we have to split our data management into two parts. We have, shall we say, small data, and then we can store the data as we have just described, either with the direct upload, with a Dropbox feature, or with a custom import. Or we can have some sort of larger data or big data, and that needs to go into the S3 storage on cosine. Here, our approach is that we manage all the metadata in OpenBIS, and we link those files, but the actual files are then stored on the S3 system. We will cover this in a separate tutorial.